Yeah. Hey, everyone. I will share my desktop and you'll let me know when you can see it. Yeah, I see this nice message telling me to not share any protected confidential stuff. That's great. I'm gonna need to wait for the timer. Got it. Thank you. And you should be able to see it. Can you see my screen?
Yes, yes.
All right, awesome. Hi, everyone. Really excited to be here virtually. Unfortunately, I was done with COVID, got it at KubeCon, unfortunately, but yeah, happy to still be here and talk to you all. It's kind of weird that you all can see me, but I can see you, but that's fine. We'll get over it. So today we're going to talk about how to write better WASM microservices with Dapr. My name is Yaron Schneider. I'm a co-founder and CTO of Diagrid, a company that I co-founded earlier in the year. Before that, I spent 6 years at Microsoft, give or take, where I focused mostly on serverless container platforms that run at very large scale and open source technologies. I created Dapr, the distributed application runtime. Before that, I created Kada, Kubernetes event-driven autoscaler with Red Hat, donated both projects to the CNCF, and as I mentioned earlier this year, founded Dagrid. So before we talk about how Dapr can help you write WASM microservices, I think we need to set the stage and really talk about what Dapr is. And so, many of you probably know an application that looks something like this, many services talking to some state management store or a queue or a pub sub message. And on the surface, this fictitious e-commerce app looks pretty simple. But when you get the nitty-gritty details of it, developers are really tasked with distributed systems challenges that they need to face every day. So for example, resiliency for their infrastructure, encrypting calls between their apps in the database, the pub sub, handling state conflicts at scale, expiring sent messages, all the real distributed system stuff that basically don't allow them to focus on business logic. And this is really where Dapr comes into play. So Dapr is a set of APIs that allow developers to focus on their business code and business logic instead of rewriting this same old boilerplate code, really hard distributed systems code over and over again, either many times in the organization or even encompassing many organizations. So Dapr has this building blocks that developers can just take advantage of via really regular HTTP and gRPC APIs, writing their code in any language, and they can consume Dapr really anywhere you can consume a container or a process. So Dapr doesn't have to be containerized, can run as a process next to your application. And this is basically how it works. You have your app here on the left, the Dapr process on the right, and then you basically communicate to Dapr via HTTP or gRPC, and you have these APIs that really help you encapsulate a lot of the hard distributed systems problems in those APIs. So you can see APIs to get in state, publish messages, create event-driven architectures, pull secrets from secret stores. And the thing is with Dapr is that it doesn't replace your existing infrastructure, it integrates with it. And so we have over, I think, 108 components today, totally contributed by the community. So developers get these consistent distributed systems APIs, but as an infrastructure person, you can basically tell Dapr to target whatever infrastructure your company feels most comfortable with behind the scenes. So if you're running on AWS, you can target DynamoDB. Then if you want to move to Google Cloud, your code doesn't change. You basically tell Dapr, hey, work against Firebase, for example. When we launched Dapr, we only had 5 or 7 components. I think I wrote all of them for the first release, but ever since then, us maintainers didn't write anything. It was all contributed by the community. This really speaks to our community momentum, which is amazing, and I want to thank Second State for being part of our community here. We have an amazing list of organizations that are contributing to Dapr, but the most exciting thing for me is I interact daily with developers who know nothing about Go. They basically come from a Python, JavaScript, C#, Java, Scala background, and they pick up Go to extend Dapr to make it useful for their organizations. And so if you contributed to Dapr and you're in the crowd right now, thank you. This is great. Today, we are the 9th largest project in CNCF, and our community is continuing to grow rapidly. And so this is really what WASM support in Dapr looks like today. So, Dapr is a process. You can communicate with it via HTTP or gRPC. It's a separate process. But recently, thanks to contributions from Intel and Tetrate, we have enabled WASM middleware. So any request that goes into Dapr can now be mutated on demand dynamically through a WASM model that you can write and basically deploy to the file system. And this is really great because it basically allows you to extend Dapr, well, first of all, in non-Go languages, and then also be able to extend Dapr with code that's existing outside of Dapr, not needing to fork the project and basically, recompile the project for new middleware that you want to include. And so this is a really big improvement for how Dapr handles request mutations. This is, pretty basic today. We've just moved to use WAS0, thanks to a nice PR that came in last week. And where we're going with this is, we really want WASM to really mature because all of the Dapr components I mentioned earlier today are compiled into the Go binary. So Dapr is written in Go, and every time we get a community contribution, this specific component that gets added, whether, it's S3 or Azure Blob Storage, needs to be compiled into the Dapr binary, which means the component itself needs to be written in Go. Now, Go is a great language. I love it. Many people love it. It's pretty easy to pick up, but there are many developers who would really like, to use the language of their choice. And today you have to write these components in Go, and you have to compile it into the Dapr binary. So for example, if you have a component that's proprietary that you can't contribute up to Dapr upstream, and you want to contribute that, you really need to go through a lot of pain to do that because you need to fork the project, create your own Dapr process or image, and then use your own version. And so if WASM maturity improves, what we'll be able to do is basically use WASM as the pluggable model for these components, because I don't know if you know Go much, but the plugin state for Go is kind of abysmal right now. And once garbage collection, multi-threading, and networking primitives are basically improving, will improve in WASM, we'll be able to look at WASM as really a way to write these pluggable components. There's lots of things that needs to happen upstream in WASM to be able to do that. And currently, unfortunately, it's impossible for Dapr to use that. But this is really where we're going with pluggable components for Dapr. And it'd be amazing if we can support that going forward. So if you're an existing WASM developer, how can Dapr help you? Well, let's walk over two limitations that you have with WASM today, where Dapr can really improve your life. So first of all, WebAssembly is a stack-based VM. There's no TCP or UDP networking primitives. You're basically dependent on a runtime to give you access to that from the host, which means there's a very limited client ecosystem there. And of course, multi-threading, WASM has a great startup time, but once you have a WASM model that started, if it's long running or if you need multi-threading in it, there's very limited support for it outside of web workers who are really more compressed towards web type of scenarios and JavaScript. And if you have really simple scenarios like multi-processing of many events coming in a multi-threaded way and really like streaming workloads of high throughput scenarios, that becomes challenging. And in many real world applications, you might want to be able to do that. So let's talk about the first thing, which is the limited TCP support. If this is a host and this is a WASM runtime here, and this is a WASM module where my cursor is currently hovering, then if you wanted to talk to Postgres, you couldn't just spin up a client inside of the WASM model and talk to Postgres. You would basically need to use something like an extension that's given to you from the WASM runtime that basically implements the driver in some way and has the networking primitives that you need. And so this is, basically the way for you to consume these extensions. WASI has a bunch of extensions. There's other runtimes that give you these extensions. WASM Edge gives you a few great ones. But, PostgreSQL, for example, is one. There are hundreds, if not thousands of, cloud services out there today, each with their own TCP stacks, HTTP stacks, or gRPC stacks and client drivers. And the ecosystem in WASM today, at least for the runtimes, isn't really standardized. It's getting worked on, but there's a lot of code that needs to be written to support each one of these client drivers for these runtimes. And so the ecosystem becomes very limited in what you can do in your connectivity. But What if you could actually use an HTTP extension from the WASM runtime, where most of them support, and be able to just use HTTP to invoke Dapr that sits outside of your WASM model? If you could do that, then you can basically tap into all of the ecosystem and all of the integrations that Dapr brings, and be able to basically consume all of these events from inside of your WASM model simply by using an HTTP extension that's provided to you by the WASM runtime of choice. And so you as a developer would basically use whatever package or module that you can link up into your WASM runtime model. That extension will probably use the networking primitives from the host, and since it's HTTP, you can just use Dapr directly, and that gives you immediate access to all of the distributed systems primitives that Dapr gives you without needing to write your own, which is extremely complex today. And gives you this really rich ecosystem. So you can just talk to state stores, pub sub brokers, all the Dapr bindings, the secret stores, and get observability with open telemetry all the way through without needing any of that piece to be supported inside of the WASM runtime or your module. What's even better is that our friend from Second State have written a Dapr WASM SDK, which is amazing because this is even a better developer experience. Instead of using an HTTP extension, you can just use a statically typed SDK for WASM from within WASM Edge. And this basically takes the networking primitive that WASM Edge as a runtime has and uses them to invoke Dapr. And there's a great demo of that online. You can search for it. And using WASM Edge, you can really use Dapr easily. This is a really great contribution. I'd really like to thank Vivian and Michael for doing that. So in terms of multi-threading and message processing, in a WASM module, you don't really have the multi-threading aspect working for you. But since Dapr is a process that sits outside of your WASM runtime and model, Dapr can actually, if you're talking about a high throughput message processing system, take these messages, perform multi-threaded operations, and then basically invoke your WASM function back with all of the events and deliver these batches of events. So, even if you did theoretically have a way to use clan drivers for pub sub systems from within your WASM model, probably multi-threading would be a blocker for you for really high throughput type of scenarios. But if Dapr can do that for you and then just invoke your WASM module back with the events, then this is a really great thing because we're utilizing Dapr for the high performance, high throughput scenario. And we can also utilize the ecosystem that Dapr has. And to allow you to connect to whatever underlying implementation you actually want to use, all while consuming either Dapr through raw HTTP or through, even better, a Dapr WASM SDK that we've shown earlier. So Dapr really improves your life as a developer, as a WASM developer, because it gives you this access to a huge ecosystem of services with like we saw earlier, with native WASM support using WASM SDK, or simply HTTP, which is a pretty simple primitives that every developer knows, and giving you high throughput and high performance while it's added. And so, yeah, I think this is it, and I will take questions now. Any questions?
Hi, hello. Can you hear me?
Yes, I can.
Hi. Yeah, I have a question. So we actually thought it could be a like standard like ABI for the Dapr part. Do you think that's a good idea? Because I haven't checked the like WASM Edge implementations, but we thought that could be a very standard like application interface. So that means that I think different WebAssembly implementations can leverage the same interface and implement that. Yeah, so that's the first question. And the second question is Dapr already provides the HTTP clients, but in WebAssembly modules, because I think a lot of implementations use the WASI experiment HTTP. So that means the Dapr client needs to be re-implemented using that way. I think how long do you think community can finish that part for like major languages? Yeah, that's the second question.
Yeah, so I'll start with the second question. I think regarding the APIs, most of the Dapr clients actually use gRPC, which is HTTP2 based today. And yes, they won't work. So you'd need to use something like the WASM SDK from Second State to invoke Dapr, or use an HTTP experimental interface to talk to Dapr directly, not through a client. But if you try and grab the existing non-WASM SDK Dapr clients today inside of your WASM model, yeah, it won't work. Which is why, again, you would either need to invoke it through raw HTTP directly through whatever extension that you're getting, either from WASI or the WASM runtime, or use an SDK that uses the runtime's own networking primitives. Regarding the first question about standardizing the interface, yes. One thing that we're doing, in CNCF is really trying to standardize the Dapr APIs. So the same way that, Kubernetes, for example, became the de facto APIs for at-scale application management and, container orchestrating, although it's really much more than container orchestrating today. We're really trying to integrate the Dapr APIs, the de facto APIs for writing these distributed systems. And we're making some headwinds with the serverless spec and others. And yeah, if that can find its way into a WASM ABI, then that's going to be really great. Because Dapr is meant to really transcend compute, right? So you should be able to leverage it from any compute platform in a way that makes sense. So for example, if you want to leverage the interface directly from WASM, you should be able to do that. Does that answer your question?
Yeah, that sounds good to me. Yeah, thank you.
All right, great. Any other questions?